we are now going to multiply radicals with unlike indexes or indices. And so what we're looking at is a problem like the cube root of 4 times the fourth root of 2. And there's two things to keep in mind here. The first is that our rule, the nth root of a times the nth root of b equals the nth root of a times b, only works if the n's are the same and the 3 and the 4 are not the same. So that we can't just multiply directly. The other thing to remember is that the nth root of a is equal to a to the 1 over n. And if we have a times b to the n, that's equal to a to the n times b to the n. We're going to use all three of these today, but we're going to do them a little bit different. But they're all going to be important. The other thing to keep in mind is that we want to worry about prime factorization. I find these problems easiest to do and make sure we simplify if our numbers are in prime factored form. So let's start with the 4. 4 is 2 and 2. So I'm going to rewrite this as the cube root of 2 squared times the fourth root of 2 to the first. I'm going to carry that 1 around. My next step is to rewrite my radicals as rational powers. So this becomes 2 squared to the 1/3 power times 2 to the 1/4 power. Well, notice that my indexes are now rational powers, and I have fractions. So I want to make these fractions the same. So we look for the LCD between 3 and 4. The LCD is 12, so we're going to rewrite this as 2 squared times 4/12 times 2 to the 4/12 times 2 to the 3/12. Well, we can go a step farther. We can rewrite our fractions as 4 over 12 is the same as 4 times 1/12, and 3/12 is 3 times 1/12. Notice we have a 1/12 in common. Well, that's like this n here that's in common. And since the n is in common, we can go backwards. We can undistribute the power, just the fraction part, to get 2 squared to the 4th times 2 cubed, all raised to the 1/12 power. Well, from here, we just need to multiply this out. So 2 squared to the 4th is 2 to the 8th times 2 to the 3rd to the 1/12. Combine our bases, 2 to the 11th to the 1/12, which is the 12th root of 2 to the 11th, and 2 to the 11th, 2 to the 10th is 1024. Double that, because that takes care of the 11, to get 2048. And so my answer is the 12th root of 2048. Notice I can't take anything out because the 11 is smaller than the 12. I have less 2's than I need. One more problem. What if we have the square root of 3 times the cube root of 18? Well, same thing. Let's break this down. 18 is 2 and 9, which is 3 and 3. So we're really looking at, and let's go to the rational powers at the same time, 3 to the 1/2 times 2 times 3 squared to the 1/3. Rewrite our fractions so they have the same power, or the same denominator in the power. So this is 3 times 1/6, and 2 times 3 squared to the 2 times 1/6. Factor out the 1/6 power, combine through multiplication like we had before, and work our powers so we get 3 cubed times 2 squared times 3 to the 4th, 2 squared, or 3 squared squared, all to the 1/6. Let's combine our bases so we get 2 squared times 3 to the 7th to the 1/6. And we're taking the 6th root of 2 squared times 3 to the 7th. I only have 2 2's. I need 6 to come out, so none of my 2's come out. But on my 3's, notice 7 is more than 6. So I can pull a single 3 out. And then 7 minus 6 is 1, so that's going to leave 1 3 still inside. And then we multiply this out. 2 squared is 4. 4 times 3 is 12. And I have multiplied my unlike indices.